This is going to be episode 3 of Scientific Inquiry and Scientific Methods. We're going to focus on controlled experiments. As always, you need to set up your notes for Cornell style. If you're not familiar with Cornell style, again, there's the video on Blackboard on how to do that. Learning objectives for this video: distinguish between the independent or test variable and the dependent outcome variable. Emphasize reliability and validity in scientific investigation. Learn about controlled variables. Distinguish between a control group and an experimental group. And go through an example of this. So when it comes to variables, there's two basic types. One is known as the independent variable. It's also known as the test variable. And you'll often see those used together. This is the one that you change on purpose when you're doing the experiment. And there's the dependent variable, also known as the outcome variable, and that's the one you're going to measure. It's the data you're collecting. It's what you expect to change when you use the independent variable. That picture is pretty explanatory about how the independent variable influences a change in the dependent variable, or no change. To identify variables, we'll use a possible experiment on rats or mice in a maze. So how could we conduct it? Well, we could put a little block of cheese in the center of the maze and try to get the mice to reach it, and we could time them. So maybe a hypothesis could be if mice are given a vitamin supplement, then they will complete the maze faster. In this case, the independent test variable is the vitamin supplement, and the dependent variable is how long it takes them to complete the maze. When we talk about scientific investigations, we have to touch on reliability and validity. When doing an experiment, to make sure it's reliable and valid, you have to only have one independent test variable. So even if you believe that more than one action or object will cause the change, you have to test them one at a time. If you do test more than one at a time, then you can't be sure which one caused the results, so you can't really conclude anything. Once you've selected the independent variable, all the other variables have to stay the same. Again, that's so that you can make sure that the independent variable was the one that causes whatever changes you see. The variables that are kept the same for all trials and experiment are considered controlled variables. So in the race in the maze for the mouse, you want to make sure the maze design you use for each trial is the same. The bait is the same, so the type of cheese or peanut butter or whatever it is. Maybe the air temperature might influence it, so you want to make sure you can control that as much as possible. The time of day you test the mouse or the mice. And then you want to make sure the species and the age of the mice are the same. And there's some other things. You could have a ton of controlled variables. The idea is try to keep them controlled as much as possible. So in most controlled experiments, you have groups for comparison. Your control group is the group that has no changes. So it does not receive the independent variable. There's nothing special done to it. It's just used to compare the group that you did add whatever the independent variable was to see if there was a difference. You can compare it and find out if that independent variable made a difference or not. The group that you're adding the independent variable to, or giving or treating with, is called the experimental group. So if you're conducting a controlled experiment and you have your mice running through a maze and you've got all your controls, one group, your control group, and they might get no supplement. And then your experimental group, they get the vitamin. And then you would time them several trials maybe take an average or a mode or a median and find out if the vitamin actually made them run the maze faster. So let's do an example. So let's say there was a study where students are claiming that if they have music, they can learn better. So you get two groups. One group taught content in a regular classroom setting, and the other group is allowed to listen to music while being taught the lesson. The hypothesis: if students are allowed to listen to music while learning, then their assessment grades will be higher. So first you have to identify the variables. The IV, independent variable, would be the music. The DV, or dependent variable, would be the test score. And then you have to think about your controlled variables. Some of them might be the instructional lessons. So what is being taught to the students needs to be taught in as close to the exact same way as possible. The environment during the lesson, so regardless of the music or no music, the temperature, time of day, classroom setting, all have to be as close to the same as possible. And then, of course, the assessment the students are given, the test they're given, has to be the exact same test. Now you look at your groups. In this case, the control group is the one that's not getting the music, so that's going to be Group A. And then your experimental group is Group B. Alright, so hopefully you got a little bit more information on the independent variable versus the dependent variable. We talked a little bit about reliability and validity in scientific investigations. We talked about controlled variables, distinguished between control groups and experimental groups, and then we went through an example. Alrighty then, all set for now.